Welcome to Bednik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand for the math. That is a spirit. Bednik Tutors. Excellence is our watchword.
Good morning, beloved. All across the world, I'm Engineer Nowe Adebayo. I will be taking the topic index notation. We discovered that indices is the basic foundation for the normal general mathematics. So we'll be doing a lot of work on index notation, which will cut across a lot of past questions, research work, as far as the topic is concerned. Just journey along with me. Primarily, if you are entering senior secondary school 1 or you're about to write WAEC and NECO and JAMB, you need this knowledge as far as index notation as a topic is concerned in mathematics and further mathematics. So join us as you also subscribe on our YouTube page. Thanks and God bless you as you join me as we start now. So we'll be starting with the laws of indices. Laws are like principles that govern a mode of operation. So we'll be looking at the laws of indices and their various applications before we now look into some examples that we were going to use to solve those questions. Thank you. So as we start, we'll be looking at the multiplication law, the multiplication law of indices. Law of indices. Primarily, in case we are given, we have a raised to power x. We call this power or index. For this power or index, we refer to this as base. So this means a raised to power x or index x. So, well, no, we will make this indices. So the plural is the index. These indices. So a is the base, x is the power. So for example, if we have something like e.g., we have 2 raised to power 3. This will be the power, while this will be the base. So if we have same way, we have something like 5 raised to power 4. This will be the power, while this will be the base. So how do we go about this? The law says that if the base are the same, you have a raised to power 1, x multiplied by a raised to power y. Since the base are the same, you pick the common base. Then you now add the power. If you are multiplying the indices. So the common base here will be a raised to power x plus y. So that's what the multiplication law says. It means that the common base, which are a, you pick it as 1, you now add the power. So from here, e.g., if we have 2 raised to power 1 times 2 raised to power 3, that will be 2 raised to power 0 plus 3, which is 1 plus 3 rather, which is equal to 2 raised to power 4. If we have 5 raised to power 2 times 5 raised to power 3, to be 5 raised to power 2 plus 3, which is 5 raised to power 5. So we've been able to confirm here that the same base, we pick the common base there, 2. Then because we are multiplying, we add the power. So multiplication law has to do with picking the common base, then adding the power. That's just the rule, provided the base are equal. If the base are not equal or the same, we can say we apply multiplication law. So let's take note of that. Then if you have any question, please ensure you ask on the comment section on our YouTube channel, and ensure you always click and like our videos after watching it. It will be a blessing unto you. So let's move to the second law. The second law we refer to as the division law. Division law. For the division law, we talk about a raised power x divided by a raised power y. And that would be a raised power x minus y. Because we pick the common base, permit me to put it here. That would be a raised power x minus y. Pick the common base, we subtract. So along the line here, if we have, here will now become 5 raised to power 6 divided by 5 raised to power 2. That will be 5 raised to power 6 minus 2, which is 5 raised to power 4. That's what the law of indices says. That's 5 raised to power 6 minus 2 is equal to 5 raised to power 4. So if I have 3 raised to power 7 divided by 3 raised to power 2, that's 3 raised to power 7 minus 2, that's 3 raised to power 5. That's what the laws of indices says. That's that for division law. So we'll move to another law, which we refer to as power law. Power law. For power law, we have a raised power x raised to power y. That will be a raised power x times y, because what power law says is that we have a base, a power, and another power outside. So when we have a base, a power, and another power outside, we have to multiply it to power. So this will now become a raised to power x y. So if we have 2 raised to power 2 raised to power 3, that's 2 raised to power 2 times 3 is equal to 2 raised to power 6. If I have 3 raised to power 2 raised to power 4, that's 2 raised to power 2 times 4, which is equal to 2 raised to power 8. In these three laws now, what we are doing majorly is the stating of the law and its application. And all this will also be settled, used to solve questions. It will also be used to solve questions. So those are some of the things we want you to take note of there. So let's move to the fourth law, which is the product power law. We'll be looking at the product power law. So for the product power law, if we have a raised to power b raised to power s. So in mathematics, we believe that if you have a base, which a base that does not have power, we have a base that does not have power, we know that that base has power 1, because in most cases, a coefficient of 1 or a power of 1 is not always visible. That is, we don't write it. The examiner will not write it there, but you must know as a student that a raised to power 1 is the same thing as 1a. So here will be a raised to power 1 times b raised to power 1 raised to power x. So here will now be a raised to power 1 times x times b raised to power 1 times x, which is equal to a raised to power x b raised to power x. So that is how product power law is being analyzed. So for example, if we have if we have 3pq raised to power 2, this will be 2 raised to power 1 times p raised to power 1 times q raised to power 1 and raised to power 2. The power 2 here will multiply all the power here that is on top of the base. What I'm saying is that the 2 will multiply 1, 2 will multiply 1 here, 2 will also multiply 1 here. So at the end we have 3 raised to power 1 times 2, p raised to power 1 times 2, q raised to power 1 times 2. So at the end we have 3 raised to power 2 times p raised to power 2 times q raised to power 2, which is equal to 3p squared q squared.
Kindly note that the answer is meant to be 9p squared q squared. It was just an oversight. Thanks for your understanding.
That's the product power law. Call it product power law. So the that's that in its illustration. So the zero index law. For the zero index law, when for the zero index law, what we are saying here is that zero index law is a type of law in such a way that just as we stated there, we multiply the power. But for the zero index law, anything raised by zero is one. That's what the law says. The law says that anything raised by zero is one. Even 1,000,000 raised by zero will still be one. A raised by zero is one. So in our illustration, we'll be looking at this. Five, we have zero index law. That's law. So it says A raised by zero is one, B raised by zero is one. E.g., we have 100 raised by zero will still be one. 1,000 raised to power 0 will still be 1. So the law says that anything raised to power 0 is always equal to 1. So that's that for the zero index law. And for the negative index law, that's what we call the negative index law. For the negative index law, if we have something like a raised to power minus x, imagine we have something like a raised to power minus x. So we believe in mathematics. The moment the power is negative, there will be a change, like a rearrangement of the base. So the base will be arranged here. So we assume that this is same thing as saying a raised to power 1 raised to power minus x. Then we now do an interchange. Denominator become denominator. Why the denominator become numerator? So we now be 1 over a. Then automatically the negativity of x here, that's what brings about the fractional base being interchanged, whereby the denominator is interchanged for the numerator. So then the negativity will go away. So at the end we have 1 raised to power x, a raised to power x. So at the end we have, because 1 raised to power any number is 1. So here will now be 1 over a raised to power x. Note, 1 raised to power x is always equal to 1. Each, if you have 1 raised to power 4 is still 1. 1 raised to power 7 is still 1. 1 raised to power 8 is 1. So those are some of the things you all need to take note of there. So for negative index law, first, there will be an interchange of the base. When the base is interchanged, then the negativity of the power will go away. And negative index law is strictly for power that are negative, be it a whole number power or a fractional power. So that is that. So we'll look at what we call, let's look at some examples now here. Power minus 3. That's 2 over 1. I told you we always, for the whole number, we believe that it will have a 1 underneath it. So I told you, in most cases, in any operation in mathematics, 1 is always acting like an invisible number, but yet it's effective. So 2 raised to power minus 3. So along the line, we'll now interchange because of the negativity. Because if there's no negativity here, we just do normal expansion. So this will be 1 over 2 raised to power 3. So at the end, we have 1 raised to the 3, we have be a power for this, will be a power for this. 1 raised to power 3 over 2 raised to power 3, which is 1 over 2 times 2 times 2, which is equal to 1 over 8. Same thing applicable here. Imagine we have 5 raised to power minus 4. That will be 5 over 1 raised to power minus 4. And because of the negativity here, we interchange 1 over 5 raised to power 4. And here will now be 1 raised to power 4 over 5 raised to power 4, which is equal to 1 times 1 times 1 times 1 over 5 times 5 times 5 times 5, which is 1 over 625. 625. So that gives us that. So let's move to the root power law. The root power law. So for the root power law, we are looking at indices that is made up of that has roots. That's it. This is indices that have roots. So looking at the root power law, I'm sure the explanation is clear to us. I'm sure the explanation is clear. So we're looking at the root power law. 7 for the root power law. For the root power law, we are considering if we have a base like something like a raised to power 1 over n. This a raised to power 1 over n. So here now the power is in form of a fraction. While the base is a, so the denominator of the base will be the root. The denominator of the power rather will be the root of the base, and the denominator will be the power of the base. So here we have n root a raised to power 1. The denominator is the root of the base, the denominator is the power of the base. So here will now be n root a. Because anything raised to power 1 is still that n root a. So that's the way the illustration is there. So for example, imagine we have e.g. 25 raised to power 1 over 2. That will be ordinary root because that's what 2 stands for. Then 25, then raised to power 1, which is 5 raised to power 1, which is equal to 5. Then imagine we have 25 raised to 125 raised to power 1 over 3. That will be third root 125 raised to power 1. I'm sure we know how to press that in our calculator. Even if we are using all these ratio calculator. That's third root 125, and that's 5. So then raised to power 1 is equal to 5. Imagine we have something like 64 raised to power 1 over 3. That's third root 64 raised to power 1. Third root 64. You press shift, then shift raised to power, then it will indicate the third root, then 64. You press it on your calculator, we have 4. 4 raised to power 1 is equal to 4. So that's that as far as the root power is concerned. So the last but not the least, we refer to it as fractional index law. Fractional index law. We're looking at fractional index law. Fractional index law. For it, which is the fraction index law. Index law. For the fraction index law, we have something like a raised to power m over n. Also, here will be, just as we have that, here will be n. And the difference between root power law is that the denominator is 1 here. Here, the denominator is more than 1. That's the difference. Everything is still the same. The numerator of the power is 1. The denominator of the power is more than 1. That's of the variable. Here will still be n root a raised to power n. For example, if we have e.g., imagine we have 4 raised to power 3 over 2. That's root 4 raised to power 3. And that's 2 raised to power 3, which is equal to what? 8. Then imagine we have 8 raised to power 4 over 3. That's third root 8 raised to power 4, which is 2 raised to power 4, which is equal to 16. So those are the ways being analyzed. So that's fractional index law. You realize that here, you start for the root, 2 here, it also start for the root. The m here is for the power, C3 here for the power, third root 8 raised to power 4. That's 2 raised to power 4, we have 16. So that's clear. So we want to look at some work examples as far as indices is concerned. work example as far as indices is concerned. Please, my best advice is this. See all those 8 laws before you journey ahead with me as far as the work example are concerned. Go and master it. Master it to the extent that you can reproduce it using any variable you want. You produce it and understand. If you can understand the first 8 law as I've written, you understand the way it is analyzed, then automatically there's no question that will come your way in indices. It will be a bonus. And most times NECO has more question in theory, but WAEC always has more in objective. That's just the trend based on my experience for the past 10 years of studying past questions. So most times NECO has more in theory. Practically, we all know that in NECO past questions. But in WAEC has more in objective. And the two are needed. So those are the things you need to take note of. Indices is not difficult. Just have the right mindset. Those students at times find it difficult to comprehend. Some, though not general, but yet it's still simple. All you need is to sit down, follow me. You will find it easy to grab these things. So mathematics is one of the easiest subjects on earth. All you need is just time and determination. If you have the time, you have the determination, you can easily get the full details and have your 100 marks. But the goal of every scientist, every engineer, every medical doctor is just for you to be mathematically inclined. Every other discovery evolves around mathematics. And subsequently, we are not only teaching you mathematics. Some of our other classes will be teaching you physics, we'll be teaching chemistry, we'll also be teaching you further mathematics purely. So in our subsequent YouTube work. So by the grace of God, all this, even including the junior mathematics and computer. So those are some of the things many tutors will be teaching you. My wife will be coming up for the junior mathematics and computer, while I'll be dealing with the mathematics, the physics, the chemistry, and further mathematics. So we have a lot to offer you. We have a lot to offer you so that to complement whatever you are being taught physically in your various classes and schools, you can stay at home with your parent phone as siblings and watch as many times as possible. So God bless you as you journey ahead with us. So let's look at the worked examples there. Let's look at the worked example. And always when you are watching online, just jot down. You're in SS1, you're in SS2, SS3, jot down. And I assure you, you can't watch us within 6 months and not feel like, oh, you are getting fulfilled as far as preparation for your external exam are concerned. Because by the grace of God, we are trained tutors who had a solid experience of 10 years that we can use to add value to you. And we produce students who had graduated, even some have even graduated from the university, studying various professions like engineering, medicine, and the likes, and nursing. So please just try and follow us up. You will see the result. Thank you. These are worked examples. So we'll be looking at this. So evaluate the following. So we'll be looking at A. Now solutions here. Solutions here. We have A, which is 8 raised by 1 over 3. So when we deal with 8 raised by 1 over 3, 8 raised by 1 over 3, we have third root 8. Just like the root power law taught us. Third root 8, then raised by 1. First, you must take note of is that you must know that when you see a question in indices, know the law. Your instinct of the knowledge, the instinct you will get through the knowledge of the law will be able to guide you because you've been able to understand all the 8 laws. So naturally, you will know the law to apply. But if you don't understand the law, it's like a barrier that will not allow you to be able to solve the question. So you must be able to first note that law. When you see a question, in a particular question, you may have 4 laws that you're going to apply, and it won't be difficult. So, but you must understand the law. The moment you can't understand the law, it's always difficult to solve any indices question. Just like formulas and the camp student. When it comes to solving questions in maths, physics, chemistry, further mathematics, the one that involve calculation, The moment you don't know the formulas, it will be difficult. There's nothing you are doing. Even to me as a teacher, the moment you don't show me the formulas, I realize that I will just assume you copy someone else. Because how will you solve when how will you know where to put your parameters or values when you don't have a formula? Even in science, the moment there's no formula, we don't accept whatever you have as theory or theorem or laws, provided such laws involve calculations. So those are some of the things there. Formulas are to prove to us that, oh, this is practicable, this is practicable. And just like in science, we are after evidence. The medical doctor is after tests. The engineers are after evidence and proof. So even as an engineer, I know that I'm after proof. And you know, engineering is an application of science. So you'll be after proof. Okay, have you done it before? What are your data? Then before we'll be able to build a principle or a theory around such. So subsequently, we have 8 raised power 1 over 3. So here will now be third root 8 raised power 1. So third root 8 will be 2. I'm sure we know how to press that in our calculator, which is 2 raised power 2. Okay, let me get my calculator in my sitting room and see how to go about that. Of calculator. So from here, we have here, you press your theory. Look at me pressing my theory. This shift, that's shift. Then you go to the HES, raised to power. Let me press again. You have theory, shift, raised to power, then 8. What do you have there? True. That's how to press. You press the number, maybe you're using 5, shift, raised to power, then 32. That will give us 5. No, true rather. That will give us 2. You have 5, shift, raised to power, 32. That will give us 2. You press 5, shift, raised to power, 32. That will give us 2. If we have third root 64, that will be 3, shift, the HES, you see it, HES there, raised to power 64, and that will give us 4. So thank you. So as we move, we'll solve that. So let's go to the B. So for the B, we have 81 raised to power 3 over 4. So just as we've told you, the denominator of that power will be the root, where the denominator will be the power. So here will now be 4th root 81 raised to power 3. And that will be 4th root 81, that's 3. So 3 raised to power 3 will be 27, which means 3 times 3 times 3, 27. So that is clear. We'll move to C. I want to clean this up. We'll move to C. To C. We'll move to C. So for C, if we have 27 raised to power minus 2 over 3. So 27 raised to power minus 2 over 3. So that will be third root. Yeah, now, before we do that, sorry about that. Before we do that, you realize that this power is negative. So here is 27 over 1 raised to power minus 2 over 3. So here will be 1 over an itachi, 27 raised to power 2 over 3. Are you doing? So here will now be third root 1 over 27 raised to power 2. Because of the negativity. If there's no negativity here, let's say this is ordinary 2 over 3, I'm not going to change it. But because of the negativity, I have to. So here will now be third root 1 over third root 27, then raised to power 1, which is 1, 3, no, raised to power 2 rather, sorry. Then raised to power 2, which is 1 raised to power 2, 2 raised to power 2, which is equal to 1 over 9. Over 9. That's some of the things there. So, as we journey ahead, we move
To be continued in our next video. Please do well to subscribe in order to receive our updated video. Thanks for watching.